cover looking at mean and median and how to calculate outliers, and then a couple of other things that you may not have picked up in years before. I don't want to recover what you've done before, but I do want to try and make sure you have got some of the more interesting features of mean and median. Firstly, how to determine an outlier. Now, there are two main ways for determining outliers. One you'll have seen before, one you won't have. Firstly, you will have seen the median one before. So median, there are two rules. Essentially, we have to establish for outliers an upper fence and a lower fence. Anything beyond the upper fence or boundary is an outlier. Anything below the lower fence or lower boundary is an outlier. Now, the equation for the upper fence is Q3 plus 1.5 times IQR, remembering that IQR is Q3, take Q1. Similarly, lower fence, Q1 minus 1.5 IQR. So you can sort of visualize it that if you take this distance on a box plot, there, multiply it by 1.5 and add it on, then anything beyond there is an outlier. And you'll note on your CAS calculators, when you plot a box plot, they'll automatically plot outliers looking like that. Similarly, 1.5 times the interquartile range this way, anything under that becomes an outlier. So, taking an example of this box plot, is 195 centimeters an outlier? Firstly, we want 195 is above the median, so all we really need to do is check the upper fence. Upper fence is equal to Q3 plus 1.5 IQR. That there would be 184. Lower one is 168, meaning the upper fence is equal to Q3, which is 184, plus 1.5 times 184 take 168, and if you throw that in your calculator, the upper fence will be 204 centimeters. Now note, if you're answering these type of questions, you must include this next bit. You would have to say 195 is less than 204 centimeters, therefore 195 centimeters is not an outlier. Now, that is when we center using the median and 5-number summary. If we choose to use the mean, remember our measure of spread for mean is standard deviation. So rather than using interquartile range to give us our upper fence and lower fence, we use standard deviation. So using the mean, the upper fence is typically given as x bar plus 2s, s being standard deviation. Lower fence x bar is the mean minus 2 standard deviations. Note, if you remember what this looks like normally distributed, not a bad one. There's our mean, 2 standard deviations out, and 2 standard deviations out will give us the central 95% of data. Meaning that in order to be an outlier, you would have to be in either the top 2.5% or the bottom 2.5%. Right. So, same concept with fences in terms of determining outliers or not, just whether we use the mean or the median. The median one is more common. Alright, mean and median visually. They do ask you to do this and estimate. So, just consider these two very small data sets. In this data set, here, 2, 3, 3, 4, the median equals 3. And the mean, all added together, divided by 4, is also 3. So, in a symmetrical data set, and you note this is symmetrical data sets, you'd expect the mean to equal the median. Right? However, in a data set that's skewed or has an outlier, look at what happens. And I know this is a very small data set. The median stays the same, it's still 3. However, in this case, the mean is 4. So what's happened is the median has stayed here, the mean is there. Meaning, for a data set that has a highly positive outlier, or you could almost think about it as positively skewed. For a positively skewed, the median will be less than the mean. Alright? So if we look at these two distributions here, this is approximately normal, or at least symmetrical, and you'd expect the mean and the median to be more or less the same place. You'd expect them to be both around here. However, here, in the population one, the median will be halfway in the heights. So imagine all of these were stacked on top of each other. You want to go to the halfway point. And the halfway point is going to be somewhere here, really. Because if you stack all that up, it's going to be similar to that, and that. So the median will fall about here. However, the mean isn't restricted to the same amount. So remember that there is median. The mean is affected by outliers. These have quite a large effect on the mean, meaning, or the significance of that is, the mean is more likely to be out here. Alright? So, when we are positive skew, remember that's positive skew, we would expect the median to be less than the mean. Similarly, or conversely, with neg skew, you would expect median to be greater than the mean. Alright. Final little item. Calculate the mean from group data. Now, this you may or may not have seen before. It's a trick that once you've seen, hopefully you won't forget. So, what this is saying is that in between 5 and 7, there are 15 items. Our issue is we don't know how many of the 15 are 5, how many of the 15 are 6, how many of the 15 are 7. When we group data into brackets, we lose precision. So really, that 15 5 to 7s could be 15 5s in a row. Equally, it could be 15 7s in a row. We don't know. So what we tend to do when working out the median is, we simply assume there are 15 of the middle point. So the best way to calculate these is write the midpoint in a separate column. The midpoint for this interval is 6, 9, 12, 15, 18. And then do the frequency times the midpoint. 6 times 15. 6 times 15 is 90. What that is saying is that we're assuming there are 15 lots of 6. And I'll pause it now to continue, but you'll see in a second. Alright, so that there is the result of all of these multiplications. Then we work out the sum of the total frequencies and the sum of this. So the sum of this is 90 plus 162 plus 324 plus 150 plus 108. 834, that will be divided by the sum of the frequencies. 15 plus 18 plus 27 plus 5. Plus 10. Sorry, where are we going from? Plus 6. 77. 834 divided by 77 is 10.8. Alright, so for us here, we expect the mean to be somewhere in the histogram of 10.8. Alright. That is all for now. So, 3 tricks. One is determining outliers. One is the relationship between mean and median in skewed data. And the other is how to find the mean from group data. All right. Thank you very much.